This section is about using random samples to make decisions about a population or process. We'll assume complete knowledge of a population. We'll use the population of monthly production costs that we discussed in the last section. Here again is a graph of the population distribution. It's a normal population with a mean of mu equals $44,000 and a standard deviation sigma of $2,500. In a typical study, we don't start with knowledge of the population. What we do is obtain a random sample and then infer from the random sample properties of the population. The goal of our approach in this section is to obtain a perspective, an understanding of the reliability of basing process level decisions on random samples. Excel's analysis toolpack was asked to simulate 4 random samples, each of 100 observations, from a normal mean 44,000, standard deviation 2,500 probability distribution. Here are the 4 dot plots of the samples. Each dot represents 1 or 2 sample observations. Here's the population mean of 44,000. The axis is expressed in terms of standard deviations from the mean. So 46,500 is 1 standard deviation above the mean, 49,000 is 2 standard deviations above the mean, and we're talking population standard deviations here and so forth. And then we can go this direction, 41,500, 1 standard deviation below the mean. Note that there's a strong resemblance between each sample distribution and the overall population distribution. Note that from inspection of the dot plots, it does seem reasonable that the sample mean and the population mean would be very close. Similarly, given the spread, it would be reasonable to assume that the sample standard deviation and the population standard deviation would be very close. What we've obtained in all 4 of these samples is a mini picture of the population. Not a perfect picture, but definitely close. When the sample data was used to compute each sample mean and each sample standard deviation, the results were: the sample mean for the first sample was $44,402. The second sample, $43,769, and so forth. The sample standard deviation for the first sample was $2,230. For the second sample, $2,279. For the third sample, $2,715, etc. Not perfect, but again, very close to the population mean of 44,000 and population standard deviation of 2,500. The number of sample observations in each sample, more than 3 or 2 or 1 sample standard deviations from the sample mean were counted. There are 100 observations in each sample, so the numbers and percentages are the same. The results were, for the first sample, there weren't any observations more than 3 standard deviations from the sample mean. The same result for the second sample and the third sample. However, in the fourth sample, there was 1 observation more than 3 standard deviations from the sample mean. You might remember from our study of normal populations, we would expect about 0.3%, approximately 0 when there's only 100 observations. In a sample of size 100, we would expect approximately 0, maybe 1 observation outside of 3 standard deviations. For 2 standard deviations, when the number of observations that were more than 2 standard deviations, sample standard deviations away from the sample means were counted, the first sample had 3, the second had 4, the third had 4, and the fourth had 2. And again, from our study of normal populations, we observe we'd expect about 5%. So we missed a little bit on those expected numbers. We would expect about 5 out of 100 in a sample of size 100 to be outside of 2 standard deviations from the mean. Remember, if you're counting dots up here, some of those dots might represent 2 observations. And finally, outside of 1 sample standard deviation from the sample mean, we would have expected, based on the population, about 32% outside of 1 standard deviation, about 32 observations, and what we obtained was something very consistent with that: 31, 35, 30, and 35 in the 4 samples. Again, the sample results and the expected results based on a normal population are quite similar. The takeaway here is that a true random sample is likely to be a mini picture of the underlying population. Using a true random sample as a basis for decision making is a credible approach.